Because of wave-particle duality then, to describe a subatomic particle like an electron, we need to specify both its wave properties and its particle properties. And if you're doing grade 12 chemistry now, you will have heard of the quantum numbers. We actually, for any electron, we can describe all its relevant wave and particle properties using a set of 4 quantum numbers that describes what we call the electron's quantum state. The first 3 numbers describe wave properties, the energy, the shape, and the orientation of the wave. The 4th one, the spin quantum number, describes a particle property. We won't get into that anymore in this course, other than to point out that there is something called the Pauli exclusion principle, proposed in 1925 by Austrian physicist Wolfgang Pauli. And what the Pauli exclusion principle says is that no 2 electrons in any atom can have exactly the same set of 4 quantum numbers. In other words, they cannot be in the same quantum state. It's like 2 people cannot have the same student number, or no 2 phones can have exactly the same phone number. No 2 electrons in an atom can have the same set of quantum numbers. They can't be in the same quantum state. Why this is important is that this is the reason why, as you learned in grade 9 and 10 science, why energy levels in atoms can only hold a certain number of electrons. Because if you try putting more than 2 electrons, say, into the first energy level, you'll end up with some electrons having the same set of quantum numbers, being in the same quantum state, and they can't do that. Okay. Without the Pauli exclusion principle, in fact, there would be no chemistry as we understand it, because you will remember that chemistry, the reaction between atoms, depends on the atoms trying to achieve a full outer energy level, and their properties are described by how many electrons, valence electrons, there are in the outer energy level. Well, without the Pauli exclusion principle, if electrons could have the same quantum state, then what would happen is all of the electrons around any atom would just pile up in the first energy level, and you'd have no valence electrons, really. Every element would have a different number of valence electrons, and so it would have completely different properties. We couldn't have the idea that all the group 1 elements in the periodic table behave a certain way, and so on. And also, you wouldn't have reactions, because no element would be trying to get a filled outer energy level, because there would be no way to fill energy levels, because you could just keep putting more and more electrons into the first energy level. So the Pauli exclusion principle, we will come back to the Pauli exclusion principle when we have our lesson on the deaths of stars.